Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. For the factoring, you should have x plus 7 times x plus 2. For the math knowledge question, the interior angles are in a ratio of 3 to 8 to 9. So we know that they add up to 180, and we can do 3x plus 8x plus 9x equals 180. Because whatever x is, they all reduce to the same 3 to 8 to 9. So 3x to 8x to 9x would still reduce because they can all divide by x. So you just basically, when they give you a ratio like this, you put a variable with them and then add them up to equal whatever it's supposed to. So 3 plus 8 plus 9 is equal to 20. And so x would equal 9. And so it wants to know what is the measure of the largest interior angle. Well, 9 times 9 is 81 degrees. And then if you wanted to check, 9 times 8 would be 72. And then 3 times 9 would be 27. And 81 plus 72 plus 27 all adds up to 180. So that's how you can check and make sure that you did it correctly. Okay, so we're looking at lesson 22 today. We're going to be looking at absolute value, and then we're going to look at reciprocal functions. So hopefully you'll understand absolute value and reciprocal functions after this lesson. So we want to graph this on a number line. The first thing that you have to do whenever you're graphing these is to isolate the absolute value part. So our absolute value is just the absolute value of x. And we need to add 2 to isolate our absolute value. Once you have isolated your absolute value, you're going to make 2 inequalities. The first one is going to look identical, except for you won't have absolute values, the signs. You'll drop the absolute value sign off. And then the second one, the left side stays as is, and then the sign of this and this switch. So instead of it being less than, it's going to be greater than. Instead of it being a 2, it's going to become a negative 2. And then we graph these 2 inequalities, and that gives us our answer. So x is less than 2 and greater than negative 2. They're open circles because there's no or equal to. And then we're going to go less than 2, so that goes this direction, and greater than negative 2, that goes this way. So they meet, and that would be the graph. Okay, we're going to look at another one. We want to graph this on the number line. So the first thing you have to do is to isolate your absolute value. And if you notice, it's already isolated. So we don't have to add or subtract anything because it's isolated. From there, we're going to make our 2 inequalities. So the first one looks identical, except for you drop your absolute value sign. And then the next one is going to be x minus 5. The left side stays the same. The sign switches, so greater than, and the sign switches, negative 2. And now on these we have to simplify it a little bit. So add 5, so x is less than 7, and add 5 again, x is greater than positive 3. So again, we're going to have open circles at 3 and 7 because we don't have or equal to. And it's less than 7, so that's going this direction. And it's greater than 3, so that's going this way. So that's what your graph should look like. Okay, we're going to look at one more. I want y'all to try this one by yourself. So first thing you want to do is isolate your absolute value, which is already isolated. Then you're going to make it x plus 2 is greater than or equal to 3. The other inequality would be x plus 2 is less than or equal to negative 3. And now we have to simplify them. So x is greater than or equal to 1, and x is less than or equal to negative 5. So now we're going to put closed dots, because they're or equal to, at the 1 and the negative 5. And then it says x is greater than or equal to 1, so greater than means it's going to be going this direction. And then x is less than negative 5 or equal to it, so that's going to be going this direction. So the way that you show that it keeps going is to shade the arrows. And so you don't have to draw it all the way out to 8. There's no need for that. I'm just going to stop it there. It's just going to keep going. So that's how that one would work. So that may be review from Algebra 2 for y'all, but that's how I recommend trying to graph absolute values. You may have been taught a different way, and if you know how to do it another way, that's completely fine with me. But this is just the most straightforward way that I've found for people to be able to get these correct. Okay, so now we're going to sketch the graph of y equals the absolute value of x. So on these, I'm just going to do a chart, and I'm going to plug in 0, 1, and -1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of -1 is 1. And so I'm going to graph those. 0, 1, 1, and -1, 1. Okay, now let's try 2 and -2. Absolute value of 2 is 2. The absolute value of -2 is 2. So we get 2, 2, and -2, 2. And if you keep going, if you want to plug in more values, you can. But it's going to be a straight line like that, and a straight line like that. Whoops, that one curved a little bit. Kind of like that. It's basically a V. When you get an absolute value, it makes a V. So that would be the graph of y equals x, the absolute value of x. All right, so now we're going to look at reciprocal functions. Reciprocal means inverted or upside down, but it doesn't mean just flip it, the graph. It means flip or upside down the equation. And so whenever we have vertical asymptotes, or whenever we have a reciprocal function, we're going to usually end up with a vertical asymptote. So it's a vertical line that is going to be approached by your graph, but it's not ever going to touch it. And the way you're going to note that it's a vertical asymptote is with a dotted line. And so that's what your vertical asymptotes are going to look like on your graphs. Your graph of your reciprocal function is going to have a vertical asymptote everywhere where the original function intersected the x-axis. Because where it intersected the x-axis is where it equaled 0. And so the reciprocal of 0 is going to be 1 over 0, and that's undefined. And so that's why we're going to have a vertical asymptote there, because it doesn't exist. So this is the original function, y equals x. If we take the reciprocal of x, that is 1 over x. And this is the graph of the reciprocal, y equals 1 over x. So the way that you do reciprocal functions, everywhere it crosses the x-axis, you're going to put a vertical asymptote. So we're going to put a vertical asymptote right here. And then everywhere that it equals either 1 or -1, you're going to put a dot. So for the y value. So the y value is 1. We're going to put a dot there. That's the only place that equals 1. The y value is equal to -1 right here, and that's the only place it equals -1. The reason 1, the reciprocal of 1, 1 over 1, is still 1. And -1, the reciprocal of -1 is still -1. Those are the only two numbers that have the same value when you take the reciprocal. And then from here, you're going to approach your asymptote and approach the x-axis. So you're going to approach the asymptote and approach the x-axis. So that's how the graph on the right can be found. So let's try and sketch the graph of the function y equals 1 over x squared. So the way the book does these on the homework, I don't like, and I'm going to go over that in just a minute. But if you look in the book, the way they do these, I'm not a big fan of. I'm going to try and do it a different way to help you out. I don't think the book really helps explain this very well. So we're going to start off by graphing y equals x squared. So that is a parabola with the vertex at 0. And then 0 squared is 0, 1 squared is 1, -1 squared is 1, 2 squared is 4, -2 squared is 4, 3 squared would be 9, -3 squared is 9. That's how you can know that it makes a parabola. Okay, so that's the original function. Now for the reciprocal, I'm going to do it in blue. Everywhere that our original crosses the x-axis, we need to put a vertical asymptote. So it crosses the x-axis here. So we need to put our vertical asymptote here. Okay? And then everywhere it equals either 1 or -1, we're going to put a dot. Well, it doesn't ever equal -1, but it equals 1 here and here. And then from there, you're going to approach your asymptote and approach your x-axis. And then on this side, we approach our x-axis and we approach our asymptote. So the blue is the graph of y equals 1 over x squared. And I'm fine with you putting them right on top of each other. You don't need to go erase the red part of it, okay? So on your homework, you get to omit 15, 25, and 26. I want y'all to pull out your book real quick and look at number 8. Y'all may need to pause the video so that everybody can pull that out. But once you're looking at number 8, they go through this long paragraph. And then at the end it says, make a sketch of the graph of the reciprocal function 1 over x plus 3. So they give you the graph of y equals x plus 3. And then they go ahead and do the vertical asymptote and they give you your points. What I want y'all to do is look at your g of x equals 1 over x plus 3 and do what I just did. Start by making it y equals x plus 3 and graph that. And then do your vertical asymptote, put your dots, and then graph the reciprocal function so that you have two graphs right on top of each other. Ignore the whole paragraph. I think it's more confusing than it is helpful. So that's what I would recommend on those. You can read through the paragraph. You may find it helpful, but over the last several years, I've found that people just get confused by the long paragraph. So we're going to do some more practice problems on reciprocal functions real quick. So I have made up 4. We don't care what the equation of these are. We could find the equations of them, but that's not what we're focused on. We're focused on, once we have the original function graphed, making the reciprocal. That's the part that people have trouble with. If they have the original, how do I get the reciprocal graph? So the first thing you're going to do, everywhere you have a function that crosses the x-axis, you're going to put a vertical line, or your vertical asymptote. So this graph crosses right here. So we're going to put a vertical asymptote here. And then it touches 1 here, and it touches -1 over here, we'll say. It doesn't do it until somewhere over here. And then after you have this part, you're going to approach your x-axis and your asymptote. And you're going to approach your x-axis and you're going to approach your asymptote. Well, let's try that part a little better. So that would be the graph that you would leave, that whole thing. Okay? So I want y'all to pause the video, make a line. It does not have to look exactly like this, but make a line that crosses somewhere around -2 and try it, and then I'm going to go over it. Okay, so for this one, your vertical asymptote should be about right here, because that's where it crosses the x-axis. And then this is going by 2s, so we'll say -1. I mean, 1 is right there, and -1 is about right there. It's just an estimate. It's okay if you're off just a little bit. And then you approach your x-axis and your asymptote. You don't ever want to touch it, so just get right up next to it. And then approach the x-axis and approach your asymptote. And that would be the graph of that one. Okay? So that's how you do lines. Now we're going to look at a parabola, because eventually they will throw in parabolas, and you need to know how to do them before they show up on your homework. So you may need to go back and watch this part of the video again whenever you get to these on your homework. So everywhere it crosses the x-axis, so that's here and here, you're going to do a vertical asymptote. And then everywhere it equals 1, which is about right here and here, and -1, you're going to put dots. So this one has multiple dots. It has more than just 2. It has 4 of them, and that's okay. So we're going to start with this one on the right. We're going to approach the x-axis, and we're going to approach the asymptote. And then over here on the left, we're going to approach the x-axis and approach the asymptote. So that's what we've been doing. Now these other 2 points. We approach the asymptote, but from here to here, all you're going to do is connect the 2. That's how you do it. You don't have to worry about approaching the x-axis or anything. You just connect the 2. So that's how you would do the reciprocal of a parabola. So I want y'all to try this one on the right here by yourself. Try it by yourself, and then I'll go over it, okay? So we're going to start off by making our vertical asymptotes here and here. And then everywhere you have 1, which is about right here, and -1, you're going to put dots. And then you're going to approach your x-axis and your asymptote. And then here, you're going to approach your asymptote, and you're just going to connect it over to the other dot, and then approach the asymptote again. And so that's how parabolas work. So hopefully that helps a little bit with reciprocal functions. What I want y'all to do now is to partner up. Y'all may have to do 3 in a group or in one group, but try to do just 2 in a group. And I want one person to draw. Let me go to the next page. I want one person to do this and then draw a line. And I want you to do another one and draw a parabola somewhere. Okay? So you make a line and a parabola, whatever you want. And then I want the other person to try and make the reciprocal. So get another colored, a colored pencil, a pen, another color, and try and make the reciprocal on top of it. And then if y'all aren't sure if they did it correctly, show it to another group and check and see. And then I want y'all to switch. So in total, each group should have 4 graphs, or if you have 3 people, you should have 6. But I want y'all to practice that for just a couple of minutes, and then y'all can get going on your homework. Okay? So hopefully that helps you just a little bit with reciprocal functions.